The next two reactions of alkynes are going to be far less useful, but we're going to look at the addition of HX, and it also follows Markovnikov's rule. The overall process here is going to be the addition of two equivalents of HX across the triple bond, and you're converting this to what we call a geminal dihalide, where the two halogen groups are on the same carbon. The mechanism is going to start off exactly like adding HX to an alkene, where you remove the proton to generate X minus, and you protonate the pi system. And then, of course, the X minus can come in and attack the newly formed carbocation. I want you to pay attention to this squiggly line notation down here, because that's to indicate that the stereochemistry is not specified, that X could be cis or trans to this proton here. And the whole process just really happens over again here. So this pi bond that's left of the alkene will now attack the HX and get protonated. It will leave the carbocation on the same side as the first equivalent of X, and that's because you can get a resonance stabilized carbocation there. And of course the byproduct once again is X minus. And X minus is going to come in and attack the resonance stabilized carbocation, and this is how you get both moles of X on the same carbon. And really the only thing that you can do with this geminal dihalide in terms of this class is to make an alkyne by doing two back-to-back E2 eliminations. However, since you have to have the alkyne to start with, this is kind of not going to be a path that we're going to take very often in terms of synthesis. As we start working through synthesis problems, it's kind of a dead end. When you have a terminal alkyne, it's going to follow Markovnikov's rule and protonate the less substituted side to leave the carbocation on the more stable side. And then you're going to get that, after a couple of steps, you're going to get that second equivalent of X minus coming in. So the bottom line is, with the terminal alkynes, the geminal halide is going to be formed on the more substituted carbon. And finally, there's no stereochemistry to consider during this reaction.